So I'm going to go through today the DocETL, which is it's about semantic steering. So this is why I put this image on. Just gives you an idea. So how do you steer textual data to get information that you want out of it? Because there's a lot of information out there that's got a lot of details, but you don't need all those details, and some of it might not even be that important, or not important at all. You know, it's just pleasantries, communication between each other in emails, or I don't know, just information within documents that just isn't relevant to the task that you want to perform. So I'm going to show you a piece of software and just to explain a bit about the software and some of the common misconceptions that came out of it, as have been explained to other people. So what is DocETL? So DocETL is a piece of software that takes in documents, which I think doesn't explain truly to everyone what that means. That takes in JSON or CSV format, and you're able to, and PDFs, that allows you to pass in that information and feed through to LLMs. So, and then you get the output that you want in the form that you want using these LLM operations. So you can think of it, if you used other techniques like Pandas or stuff like that, where you pass in tabular data and then you work on it and you get the information that you want using a series of commands. Well, this is how you do it for the LLM age. You can do this in Pandas, but it doesn't include everything. So what this does beautifully, it includes the outer loop, so the start, and then also the end process. And the end processes are probably the most important because it allows you to view the information that's been processed through the LLM operations in a graphical format and write comments on it against the data in situ. So in situ just means it's if you're writing comments about a particular piece or column of that data, it stores that information against that piece of information. And that's useful later on in the process because you can update the prompt and get assistance from the LLM to update the prompt based on your comments, because it passes the comments plus the data and the LLM understands that. So if you've got because it knows what you're asking for it and it knows what your comments are, it can then update the prompt to be a bit more clear about what you actually want. And it also gives you records to actually look back through. So it helps you work with the LLM, perform these LLM operations. There's other things that it does as well, like once you've got all these comments on there, because you've got the prompt, you know what you want out of the data, and then you've got the data at the end, an LLM-as-a-judge, or optimize the process. So you can create all these LLM operations and get the system to do that, and it automatically does that after each iteration. So it'll change the prompt, change the operations, view the output. Does it match what the prompt actually asks for? No. Okay, how do I improve this? The LLM will decide on that and it'll update it, and it'll keep you doing that iteratively until it gets to something that it thinks is valid. Yeah, so it's how it's all inbuilt and the flow, I think, is what makes this different. I've done these operations before, but until I saw this software, I thought, this is it. This is when it really clicked for me, how important it is. And I get people talking about LLMs and how that we're at the end of this current LLM improvements, which I don't know if we are. I don't think we are. I think there's a lot of improvement from the data that we put into the LLMs to the architecture. I think there's going to be some improvements there. Even using transformers, there's a lot of room for improvement in terms of efficiency, different optimizers and all that kind of stuff. And there's also going to be improvements in hardware as well, so it means you can make bigger models, run cheaper and less power. So I don't think there's any slowdown. But even if we did have slowdowns, we've still not utilised everything that LLMs, and I think this is just one use case of it. So let's dive into it. So DocETL is over here, and this is the main screen. So you can go to, and you've got a website that you can go to. It's got the playground, and you can upload your data set. So the data set's here on the left hand side, and then you can click on the data set here on the right hand side to toggle it on and off, and this gives you the data that's in there. So you can see it's got a list, and then a dictionary, the statistics of it. This is how many documents are in there. So there's 250 records, if you like. And then it's got 306 words per document. A minimum words 196, maximum words 920, and the standard deviation is 111 to these average 306. And these are the columns in the data. So you've got agent, duration, section. So if we look at this data set, I know when I imported it, you can go here, airline and comparison. So this is the very first time I've actually looked at this data. So it's come from Kaggle. So let's have a look about what this is. Okay, so customer service chat data of more than 30,000 rows. So you can do sentiment analysis on it. They're going to give us any more information. No, it's not. Gives you a bunch of notebooks that someone's been using. But yeah, we'll leave that there. We'll just explore the data ourselves. And then this is the pipeline that they've got. They've got a map operation, which I'll show you what that is. So analyze individual chats to identify complaints, categorize issues, and reassess customer frustration. And then reduce summarizes those across common complaints patterns to get the themes out of it. So the first one is getting the themes from each stat, and then you're summarizing those based on common themes between all those. So there's a number of operations that you're performing to get to what you want to do. So you could probably do some of this all in. If you had a large enough context, you could just throw this all into an LLM. But because you're working with large datas, you're extracting the value out of the individual records or documents, and then based on that extracted information, you're doing the summarization. So this isn't a lot of data that we're looking at the moment. What is it? 250 documents? Tiny. But you might have thousands. So this might all fit in the context of a large language model. But you work on the principle that you're not to use the software. Large use case. So down at the bottom is where we've got the customer data. So that's, let's have a look at this. So this is looking at the output. So let's have a look at the description. So describe the chief complaint from the user, including direct quotes from the user to capture their exact words. And then this is what's inputting the data in there. So this is this data on the right hand side, which is input.text. We should have text here. Text, there we are. So that's going to put it into this prompt. So for every record, it's going to insert the text in from that. And then it says, additionally, categorize complaints into one of the following categories: pricing, tech issues, user error, customer service, or analytic assistance. Ensure the category is lowercase. Determine the level of frustration expressed by the user, using values medium, high, low. So you're categorizing the data and getting the tone, if you like. Also, note to the user status of the airline, frequent flyer members, include negative comments or experiences mentioned by the user. Additionally, if the user provides any positive comments, please note those as well. Format the output as following. So, chief complaint, complaint category, frustration level, user status, negative comments, positive comments, example output, a demo of what you actually look at. This helps the LLM understand how it should be outputted. And this is how you structure it. So this is giving it a bit of a guidance to how it wants, and then this is giving it the actual structure that you're going to get out. It's helpful when you do this to match out the output examples. So, you're trying to tell the LLM how to output it, and then this enforces it. And this is where you put a PDF if you've got a PDF, but in this data we don't. And then this is the second operation to reduce. So this loops through and extracts and summarizes information further. So what we can do up here is we can show outputs. Yeah. So you can see this values have changed here. So this is the raw data. And then we've added the extra columns. So you can see text here. This is the information it's actually passed in here. So there's a lot of useful information here. I'll show you another way to access that as well. And then this is the new columns. So let's just get those up. So the new columns, chief complaint, so that's here. So this is a column the LLMs already created. Just scroll down. And then here we've got the customer service. And this one is the frustration level. So if you click this button here, you can see the data. What I find useful when I was going through this is if you display the text, you can see how it's got this data, and then you can write any comments in here and then assign a category, a colour. So absolutely terrible nightmarish experience with flight, not worth the headache, and lack of transparency. Embarrassing that this is a Canadian company. Okay, so it's a Canadian airline data that we've got. Okay, so here is the description of my terrible experience, how it's getting it. You can see it's got a lot more information in here than what's needed by the chief complaint. All you're looking for is a summary of this, so a semantic understanding of what it is. So I call flight number to book and ensure the sample price flights. Then the agent tells me that I'm seeing this due to, okay, so I've got some funny text in there. It's 30 minutes call. So this is going through the complaint, point to point, what actually happened. So there's here. Okay, so yeah, they're not happy. Not worth the headache, transparency. So not worth the headache, transparency. Embarrassing, this is coming. So it's extracted this bit from it. So a bit from the start and also a bit from the end, and that tells us. So I don't know. For this one, we could say very good description, but would like more details. I'm not saying we do, but I'm just giving an example of what we could do, and then click save, and then we'll just go through here, through all the other records. So this is the next document, and then we can just see what the actual complaint was. So this one's a lot longer, so this one we can say make this shorter, then add. Okay, so I've added 2 complaints. So on this left hand side we've got notes, this away, we've got these 2 notes here, and you can see it's got a very good description but would like more detail, and then it's got the record as well. So this is what it means by locality of the data, because every time it's going to send this comment, it's going to say this comment is in reference to this record here, and that's going to be beneficial to when we update the prompt. So this is the prompt up here. What we can do is we can click on this button, which is improve prompt, and then in here we've got the prompt, the original prompt, and if you look here, it's got those notes. So it's not going to send just those notes that you see here, it's going to send the records with that, so the whole description, so all of these columns related to these comments. So if we say improve province, and then you can just add any more specific information that you want. So for example, let's just say continue, and this is just going to run through and suggest some improvements, and it's going to give a analysis, a bit like a Git sort of text, so show you what we've currently got, and what it's going to remove, and then what it's going to add. I'm not particularly interested in doing this. I just wanted to show you how it works and how you can do it. So you can decide here, you can do direct import, direct out, and then yeah, you can improve that and keep improving it, and then you just run it again to run everything through is super useful to have all that information locally there and to have that prompting, so you don't have to open a ChatGPT or some other sort of LLM to get that information and help you build the prompt. Go there, and then we've got a reduce. I'm not going to do it, but I'm going to show you what the reduce is. And that you can just have serial operations going down. They just work and update the content here. So because the person who designed this has added a reduce, all these columns aren't going to exist anymore. What we'll need to do is on this operation, which they show outputs. So this is showing it on the reduce, and we can see that we've got less columns. So we've got complaint history, frustration level, chief complaint, and this is summarized from then. So we've reduced from 250 inputs to one input. So there's going to be one document, so one master document for those complaints. So summarize all complaints across tickets, and that's what we've got here. And then we've got count. So if we just click in this column here, this is what your typical exec would want to look at, or someone who's and we've got all that we've had an operator talk to all these customers, all these complaints, how can we improve, where were all the faults, and this just summarises it for the exec. You can imagine this can run quickly every day. Every day tickets get updated, and you can quickly get the execs can quickly get updated to where we are. Yeah, so this is a summary of everything. Overbooking, misleading practices, there's all sorts in there. So that's super useful, and we can visualise those outputs. Is there anything else that I need to show in here? Yep, there's this one where you can optimize operation. I'm not actually going to run it, but this uses the LLM-as-a-judge. So this is what I was talking about at the start, where it takes the prompt, takes any comments you've done, takes the output, and it optimizes the inputs between the operations between the input data and the output data, using an LLM to help you do that. And it'll just keep going through until it feels it's got the right place. And that is the software. So this is the paper. I recommend reading the paper. It's something that I've gone through, made comments about. Like it's saying, the common operations you use is map, reduce, and filter. Talking about types of it, yeah, it uses quite a lot of technical words, so it is used for an academic. This one's a bit more technical, but it is a useful paper to read through. Just have a LLM at the side of it to just query and have a look, see what the comments were. Decomposition, which means reduce the operations into smaller operations, just so you don't confuse the LLMs. So that's something I didn't touch on. You can use different models. So in here you've got GPT-4o Mini, GPT-5 Mini, or the lower one, which is Nano, I think now. Or you can use the larger models, but obviously it's going to cost a lot more if you use the larger. So the larger models, you can use more complex queries as well, and more themes in that queries. But it's going to cost you a lot more. So you just got to weigh up what's useful to you. What can you get away with essentially, using the lower models, and then use the larger models when you need to. If money's no object, stick it through a large model. But for the majority of us, it does make a difference. So let's go back through the paper. So this is talking about the inner loop versus the outer loop. It's got all the screenshots. I found screenshots quite difficult to follow. I found just using the software and looking at YouTube videos the easiest way. That's why I created this little YouTube, just to show you the quick sort of elements to it. But yeah, I'm not going to go through it all. I'm just showing you it's there. There's lots of bits there that are useful. If you've got any questions or got any queries, just let me know. And